Hello, I have two colleagues, Ian Jarrah and Donal Cunningham, who are standing in the wings. I'm going to rush through all the overview of OpenNMS for you very, very quickly so that they can have something to say about their deployments. But this is basically trying to give you an idea of where and how OpenNMS can be used. Can I ask a question? Who has heard of OpenNMS? Wow. Who uses OpenNMS? Ah. Right, hopefully I'll turn that around. Just to give you a very quick background on myself, I worked for Nortel for a load of years where I was a product manager and I contributed greatly to the bankruptcy of the company. After which I think there's a few of you here as well, after which I then went off and did a doctorate at the University of Southampton, Tim Chown's school, and that was looking at open source and telecoms. And the principal finding of that was that it's very difficult to integrate a lot of systems when the basic business model of all your vendors is to hide information from you. And that's how I got involved in open source and hence in OpenNMS. So I'm going to give you an overview of OpenNMS, and then we have two use cases, one from Airspeed in Ireland and one from Arqiva here in the UK. And then finally I'll do a quick little pitch on the futures and what we're doing. So what is OpenNMS? Well, Open Network Management System. We like to say it's the first enterprise and carrier-grade network and infrastructure management platform developed under the open source model. First, it's been going for over 10 years. It started around about the same time as Nagios. Enterprise and carrier-grade, well, you can run it on your laptop, and a lot of people do, just use it for managing small infrastructure. But the people who actually pay us money tend to be running hundreds or thousands of nodes and have very big infrastructure that they use OpenNMS for. It's written in Java. You can download it and use it for free, and it's available on the internet. It's made by a great community, some of whom work for the OpenNMS group or for other companies that are involved in the actual development of OpenNMS, but the majority of whom are actually people who use OpenNMS in their day-to-day job as sysadmins, and they want to make contributions to actually get the thing to do what they need it to do. It's licensed as GPL, and it's governed by something called the Order of the Green Polo, which is a group of individuals who, by merit, have become able to commit code into OpenNMS. We have an OpenNMS Foundation based here in Europe that runs the conferences basically, but we may expand that to do more in terms of owning governance of the project. So that's OpenNMS as a project. Let me talk very briefly from a capability perspective. Basically, OpenNMS is a service assurance platform. We do fault and performance. We don't do configuration. We don't do all the other things that you might expect. We don't do trouble ticketing. But we do service assurance very well and provide lots of ways of integrating into those other things you would have in your infrastructure. When we talk about next generation services, OpenNMS manages things in all layers. So this is a simple diagram showing, underlying hardware, then virtualized infrastructure, and then actual applications above that. Well, OpenNMS can gather data in all of these areas and present you a unified view of what's going on. When people hear NMS, they think SNMP, routers. Well, yes, we do that, but we also can manage any other network or compute infrastructure that you have. In terms of the value of OpenNMS to an organization, this is the business process map from the TM forum. We won't be able to read all of it, but basically it outlines the various processes that you typically have in a service provider. And OpenNMS provides value in all of these areas in terms of information that can go to different parts of your organization. It's a multi-user system, and we can partition views according to what you need. That's from a fault perspective. From a performance perspective, exactly the same thing. We can give views that are customized to customers or to account groups or to the network engineering function or to the functions that actually plan your network going forwards. In terms of data collection, we can collect from all layers, as I said, and there's multiple protocols we can do that with. And we also have remote pollers, which can actually be planted out in different address spaces and then report back to OpenNMS the view from that address space. So, for instance, Papa John's in the USA, all of their shops in the USA have a little bit of OpenNMS that can monitor their access to the data center from the shop and then tell the central administrators that there is a problem of this shop ordering pizzas. That's what that technology is used for. In terms of scalability, well, you can measure scalability in many different ways. So Swisscom, for instance, use it to manage all of their Wi-Fi hotspots around Europe. Again, 60,000 devices plus. New edge networks in the US, 1.2 million data points every 5 minutes are collected and rendered up as displays for customers. So when they log in and want to see performance in their network, it's coming from OpenNMS. Wind in Italy are using it to manage their core network, so lots of interfaces on individual devices. And the Savannah River, I think it's Savannah River Network System or whatever, they actually manage all the atomic energy in the United States. They look after the uranium and such. 2,000 effects per second coming into OpenNMS there. And then finally, Papa John's Pizzas, as I mentioned, lots of remote pollers. So it is proven in terms of scalability, which is something a lot of open source projects can't say. In terms of providing views to individuals, you can see different types of reports and different types of views. I won't go into this in any detail. Similarly for performance, same sort of thing. And obviously we alert on performance thresholds crossing. We've just introduced a new wallboard feature. Obviously, usually in data centers, you see big wallboards, that are absolutely useless but are wonderful for marketing. Ours is probably absolutely useless as well. But the one thing we've introduced in it is the idea that it rotates multiple views of your network. So it gradually works its way through all the views of the network. If there is a problem, it will stick. And that way, a user can notice that it's stuck. There is a problem on this page. And then they can drop in and say, well, what is the issue here? In terms of views of your network, you can obviously see a geographical view where we paste whatever information we have on Google Maps or on OpenStreetMap. Or we've got a new topology view now where we discover the topology at layer 2. And we can show the relationship between devices. So if you've got a problem, you can click on the device and then look at all the connected devices to see if there's issues there as well. Lots of people are using it. We've no idea who's using it overall. We got something like 1,000 downloads a week. So we estimate there are many, many, many instances of OpenNMS installed. In terms of people who are paying us money, they tend to be large companies who have particularly critical infrastructure, and this would be a list of some of them. So that's enough said from me. I'm going to hand over to Donal Cunningham from Airspeed Telecom, who's a user of OpenNMS in Ireland.
Good afternoon, everyone. Can you all see me, and can you all hear me? God help you all. I work for Airspeed Telecom, which is an Irish telecommunications company running probably the largest licensed wireless network in Ireland that isn't a mobile operator. And we have a lot of customers, several of whose logos you'll see. We have a lot of connections in the media world. So if you're watching sports ball from the Aviva or Lansdowne Road, as you would have known it, or indeed from Croke Park in Ireland, you're probably watching it using a part of our network. We feed all of the TV providers in Ireland with differing kinds of services. And for the purposes of a small piece of paper, we do not use carrier-grade NAT. Our customers do big data. We're not IPv6 only, and I have no idea what a thought leader is, but somebody thought it was important I should mention it. And this is not a sales pitch. The network is quite mixed. We started off doing a lot of wireless point-to-point and multi-point. We'd have several thousand radios in the network, and we're spread across Ireland and into Northern Ireland as well. And we have a presence here in London in a data centre you may all know well. We provide a lot of different services, ranging from intranet to managed services such as firewalls, cloud services, again an important word I'm led to believe, but we also do SIP, and we do a lot of webcasting as well, and as part of, again, the media focus of the business. OpenNMS is our primary monitoring system. We've been using it for several years now, and we have contributed both funds and time to assisting with the code base, and it's grown with the business over the last 5 years. As a network engineer myself, we do find it quite useful, particularly the things that we find most useful are once your baseline templates are set up, it really does make it very easy to add similar devices of that type, and we've been able to integrate some of the more esoteric radio devices in as well and get proper visibility of those. In particular, being able to group particular types of alerts together, again with a particularly large radio footprint, We do see some interesting things which those of you who are blessed with networks made of nothing but magic pixie dust and fibre don't ever get to see, and for which you should be very grateful. We find that it's very configurable, and as I said, we've configured it ourselves, and our sysadmin and development team can get into the code themselves and make whatever changes they have to. And I don't see us changing to any other system anytime soon. I'll try and keep it nice and brief. Does anyone have any questions? I'd run down and get you a microphone myself, but mine's on the table over there.
Maybe we'll take one now and then we'll take some more at the end.
Hello. I'll just assume you can hear me. There we go. Yeah, so two very quick questions. Number one, I've been running OpenNMS at my place of work for about 3 years now. We've gone from 1.8 to 1.10 to 14, and it is incredibly hard to get first configuration done when you're doing it in Puppet between versions. Is there any way that you guys can improve the installer somewhat, because it is really hard to use on things like CentOS 6. I mean, it needs huge amounts of Java screwing around. It is not an install that I was particularly happy with. Once it's up and running, it's great, but the installer, especially integrating with things like LDAP, is just a nightmare.
Okay, quick answer, you could pay for support.
Yeah, I
know. But other than that, I mean, let's talk later. Let's not get into that now. What was your second question?
The second question is, would you mind saying the word white space for me?
Why would I say white space?
Oh, well, okay. I've got a house. Yay!
Great. Okay, so very quickly, Ian Jarrett from Arqiva is now going to talk about their deployment, which is quite different to what's gone on in Airspeed.
Thanks, Craig. Okay, so very quickly, our tower there is bigger than the Shard by 20 metres. We're rather proud of that. So, yeah, my name's Ian Jarrett. I work at Arqiva in the UK. Not many people have heard of Arqiva. Hands up if you have heard of Arqiva. Ooh, more than I thought. Good. So if you watch TV or listen to the radio in the UK, you're using our networks. We also have a number of other private networks in the UK. We're a user of OpenNMS. Craig has invited me here to talk about what we do with it, and I thought, well, for this audience, we'll talk about BGP. One of the other networks we have, by the way, is Internet of Things. It's on a piece of paper I've got. Yes. Okay, so a few slides about Arqiva, which I've just spoken about. Don't want to spend too much time on that. Okay, so we provide a private network for a number of energy companies in the UK, and we peer with them, and we provide the backbone for them to talk to one another. Don't really talk about it that much, but in this particular instance, we've got OpenNMS that's monitoring all of the BGP peers in this network. One of the problems we had was when we lost links to peers, we didn't really know who was impacted, so we wanted to be able to find out things like customer name, circuit details, that kind of thing. We've been using OpenNMS for a while. It is a great toolkit if you want to manage weird and wonderful bits of kit, and there is some weird and wonderful bits of kit in Arqiva. We just got rid of our DEC VAX, actually, so we've got stuff going back a long time. And OpenNMS is a great toolkit, and Craig didn't mention that, but I see it as a toolkit. So in this particular case, we built it around monitoring BGP. So this is the kind of network that we've got. Some of our big routers peer with the energy companies. And it's really not rocket science, really. All we're doing is we receive SNMP traps from these peers when they go down. We monitor them continuously to look at the state of the connections that they have to their peers. Really, when a state goes from established to anything else, we get an alarm on our OpenNMS system. We also collect this information, so we've got some good data that we can show to customers about how great the service has been. Also, we have an ability to augment this. I don't think I've got it on here, but we augment this information with a lot of details, such as customer name, circuit details, address, etc., contact details, so that when our NOC moves into action, we can actually, we know who to be speaking to, what the customer name is, who the contact person is. And OpenNMS has proven to be a really good toolkit for us. And, if you don't use it, I recommend you take a look. Okay, I think the summary slide. The last thing I've got to say is cost effective, obviously. As Craig said, it's open source. A big fan of open source myself. I think I recommend you use more of it if you don't already. There are a number of projects sort of around the OpenNMS solar system, if you like, that are worth exploring. Personally, I think OpenNMS has proven very useful for us. It's very good for SNMP integration, but we've got it looking at all kinds of other stuff. If you use JMX at all, it's another good tool for that. Highly flexible, as we've got a number of systems, and we also pay for support. So it's good to know that if things break, and to be honest, in 5 years, I don't think they have broken, have they? So it's pretty reliable stuff as well. Okay, I think that's me done. I'll hand back to Craig now. Thank you.
Great. Thank you, Ian. Two very different use cases. Obviously, Airspeed are using it, as their core system, whereas Arqiva are not using it as their core system. They're using it for a lot of point cases where they have a requirement where to actually buy in a system or modify their core systems to do that requirement. It would cost them a lot, and OpenNMS is flexible enough for them to use it in that way. So again, it's a tool you can use, big or small, depending on what your requirements are. Very quickly, I'm going to talk about where we're going with OpenNMS because we're constantly developing it and moving it forwards. And basically to say that OpenNMS, as you will see it in the next couple of years, will be very different to the beast it is now. We're moving to a very distributed architecture. We're introducing a lot of service-oriented architecture technology with the view that OpenNMS will be distributed around your data centers and having multiple blade servers, basically with bits of OpenNMS in it, actually monitoring a data center and then reporting back to a central system what's going on. It'll be very modularized, and it'll be much easier for people to write modules to actually plug into an OpenNMS installation instead of dealing with the sort of configuration issues that were raised earlier on. And part of what we're trying to do is address that configuration problem in what we're doing. One of the big things that we're working on is actually replacing the RRD tool capability, which we use to store performance data at the moment, with a back-end store based on Apache Cassandra. That will make a very, very scalable, distributed and replicatable infrastructure for storing very large amounts of performance data. Dramatically changes the model that OpenNMS uses. But all the value you've got in OpenNMS in terms of collecting the data will remain, but it will be feeding into that core data store instead of into separate RD tools. So that's a big thing. We've already got part of this out there. It's called NEWTS. Newfangled time series data store. It's up on GitHub. If anybody's interested in that as a project in its own right, you can look at that. Finally, just to say, if you haven't used OpenNMS or if you've used it a long time ago, it has gone through a lot of change over the recent years. Download and give it a try. We want to become a commodity, that's another one on the list, service assurance platform for large-scale users like service providers. So it just becomes a no-brainer. Why would you not use OpenNMS and integrate it into your higher-level OSSs? People like Juniper Networks are believing in us. They've embedded OpenNMS into their space product. And we're hoping that other vendors will take a similar route because we believe OpenNMS will be a commodity but very powerful service assurance platform that can be leveraged by other vendors. You can download and use it. You can contribute in many ways. And we need help. If it doesn't quite do what you want now, you can join the project and help us to get it to where you need it to be. So with that, I'm going to stop and perhaps ask my two colleagues to come back, and we'll take any other questions if we have time for it. Now, thank you. Microphone? Yeah.
Hi, Nat Morris. I've got a question about your open source project. How do you handle contributions from the community, and how many people have commit rights to your master repo? And
we have about 40 people with commit rights. They're the OGP. Contributions are variable, so to be honest, the majority of people that contribute configurations. So they'll say, I've got a new router, I've done this config for it, here we go. Those are very easy to handle, and we'll pick those up and use them quickly. If it's a serious code contribution, then we have a developers conference once a year. We encourage people who've got a big bit of code they want to contribute to come along to that, and we'll spend the week working with them to get it integrated. One of the things we're moving to is using OSGI, which is a much more modular architecture. That will make it an awful lot easier for independent contributors to plug in modules that won't actually affect the core of OpenNMS. That's one of the big reasons why we're moving to that.
Okay. Do you expect that people that contribute produce unit tests at all? Or
yes.
Okay.
We used test-driven development throughout, and we'll help them to try and do that as part of their process of developing a contribution.
Thank you.
Somebody at the back.
Hi, John Mulberry from Fido. I was just really echoing the comments from earlier. We tried installing this about a year ago and gave up. It was horrible. Didn't actually get to try the software. Just the install process was horrible. I think
what were you installing on?
CentOS 6. We are 99.9% CentOS based.
Okay.
So I think if you want this to become the next big thing, then you need to work on the installer. And we're not going to think about buying support until we've tested it and tried it and played with it and thought about rolling it out, at which stage we might think about paying for it. Okay,
we can have a chat later. I mean, I'm surprised to hear you say that, because most people I know can set it up within an hour on CentOS very, very easily. So obviously there's been some issues there that we aren't aware of. But fair enough. Anybody else? Okay, well, thank you to my two colleagues who've presented, and thank you very much for your time and interest. Thank you.